In this video we're going to start off in a direction which is going to lead us to an unbiased estimator for sigma squared. So in the last video we considered the expectation of u hat primed times u hat, given that we had our matrix of independent variables x. And what we're going to do in this video is we're going to demonstrate that this is exactly the same as saying we're going to take the expectation of the trace of u hat times u hat primed, given that we have x. Okay, so why are these two things necessarily the same? Well, we know from the last video that u hat primed times u hat is just equivalent to summing from I equals 1 to n u hat I all squared. So we need to demonstrate that the right hand side is actually equivalent to this. So if we write down u hat times u hat primed, then writing it out in sort of vector form, this is u hat 1, u hat 2, all the way through to u hat n, and then we're multiplying that by the transpose of the vector, which is just going to be u hat 1, all the way through to u hat n. Okay, so what happens when you multiply these two things out? Well, what you get is you're going to get the first term is just going to be this times that, so that's just going to be u hat 1 all squared. The second term is going to be u hat 1 times u hat 2, so that's going to be the next component along in the row, in the next column rather, so that's just going to be u hat 1 times u hat 2. And then we're going to continue all the way to the last column in the first row, which is just going to be u hat 1 times, oh sorry, it's not a vector, u hat 1 times u hat n. And that just comes from taking the first element of the first vector and multiplying it by the last element in the last vector. Okay, what about the next row? Well, the first element is just going to be the same as the second element in the first row, so it's just going to be u hat 2 times u hat 1, which is the same as u hat 1 times u hat 2, so it looks like our matrix is going to be symmetric. The next component is then going to be u hat 2 times u hat 2, so that's just going to be u hat 2 all squared, and we can sort of continue filling out in the entries that way and also down in the columns. So our last entry, if we think about what that's going to be, well, it's just going to be u hat n times u hat n, so that's just going to be u hat n all squared. So I hope you can see that the trace here of this particular matrix, if I sort of outline it, is just going to be these square terms which we find here on the diagonal, because the trace is just summing together all the diagonal elements. So it's absolutely identical to this expression here. So we know that the trace of this, which is the trace of this, which in turn is just going to be the trace of this whole matrix here, I hope you can see that this is just going to be equal to the sum of the diagonal elements, which is just the sum from I equals 1 to n of u hat I all squared. So when we take the expectation of this, it's just going to be equal to the expectation of u hat u hat primed times u hat given x. So the left and the right hand side are absolutely identical.